Good morning, dear students. Welcome again. Today, first of all, we will revise how the chemical formula of any crystalline substance can be predicted with the help of number of atoms present in unit cell. So, for understanding, consider following pattern of problems. Our first problem is in an ionic crystal PQ, p ions are present at each corner as well as each is center of the cube, while Q ions are present at each face center of the cube. Find the simplest formula of this crystal. So according to this numerical, a ionic crystal PQ is given. P ions are present at each corner as well as each is center. So we can write what? Total contribution of P is equal to 8 into 1 by 8 plus 12 into 1 by 4. This is what? We know that contribution from one corner lattice point is equal to 1 by 8. Total number of corner is equal to what? 8. And contribution from one is center of the cube is equal to what? 1 by 4. The total number of edges is equal to 12. So 12 into 1 by 4. This is contribution by what? Each is center of the cube. Here the contribution is equal to what? Contribution present at each corner. So we can write 1 plus 3 is equal to 4. Again, Q ions are present at each face center. We know that contribution from one phase lattice point is equal to what? 1 by 2. And total number of phases present is equal to 6. So total contribution 6 into 1 by 2. So we can write total contribution of Q is equal to 6 into 1 by 2 is equal to what? 3. Therefore, formula of chemical become, we can write P4 Q3. P4 Q3 is the chemical formula of our ionic crystal. So, when number of atoms present in unit cell is known, we can easily predict the formula of crystalline substance. Our next problem is in solid crystal AB, atoms of A are present at 50% corners, while atoms B are present 25% phase centers. Hence, calculate simplest formula of this compound. This numerical is similar to previous one, so we can write what? Contribution of A through corner contribution is equal to 1 by 8. Total number of corner is equal to what? 8. But occupy 50%. So we can write what? 4. 1 by 2. Contribution of B through face, we know that contribution is equal to what? 1 by 2. Total number of faces 6, but here 25% B. So 6 divided by 2 is equal to what? 3, 50%. And the half of, then again we divide 2, it gives 25%. So we can write what? 3 by 2. 3 by 4. Here the contribution of B, here the contribution of A. Therefore, formula become what? A 1 by 2, B 3 by 4. This is not a whole number. So in whole number we can write A, if we multiplied 4, here also 4, we get what? A2 and B3. So the stoichiometric coefficient is always a whole number. Therefore, the atomicity of A is equal to 2 and the atomicity of B is equal to what? 3. In this crystalline substance. Our next problem is in solid PQ having NaCl structure, P atoms occupy the corner of the cubic unit cell. If all the face centered atoms along one axis are removed, then resulting stoichiometry of the solid become dust. Here in question, a solid PQ is given. The structure of PQ is similar to what? NaCl. P atom occupy the corner of the cube unit cell. If all the face center atom along one axis are removed, so we can write what? Removal of face center atom along one axis means what? Removal of two atoms. One axis contained how many number of atoms? 2. So 2 atoms are removed. So atoms of P per unit cell is equal to what? Contribution through corner, contribution through face 1 by 2. So face multiply by what? 4, not 6. 1 plus 2, it means what? 3. atoms of Q per unit cell is equal to what? 1 by 8 into 8 plus 1 by 2 into 6. 1 plus 3 means what? 4. We know that in NaCl, Cl minus arranged, atoms are present at corner as well as face. So this is contribution through corner, this is contribution through what? Face. B, that is Q become unchangeable. So our formula become what? So the formula of chemical become, we can write what? A3 and B4. 3 plus 1, 4. This is the formula of our given chemical. Always remember some important points. Notes number 1. Yeah, we can say if number of particles in a lattice is equal to n, then number of simple cubic unit cell is equal to what? N. SC matlab simple cubic. Second one, number of BCC, body center cubic unit cell is equal to what? N by 2. And third one, number of FCC, face center cubic unit cell, is equal to N by 4. So if number of particles in a lattice is given, then we can find out the number of unit cell. Here N by 2, in last case N upon 4. Our next term is coordination number. This is a very important term. With the help of coordination number, we can find out the geometry of any crystalline substance. So, the number of nearest neighbor of an atom called coordination number. Crystal coordination number. Some crystal and their coordination number always remember. First one, NaCl. Coordination number become equal to what? 6:6. The coordination number of sodium is 6 and Cl minus is also what? 6. Second one, cesium chloride, 8:8. Third one, ZnS. ZnS is called what? Zinc blend, 4:4. Next one, calcium fluoride, 8:4. Similarly, for Na2O, sodium oxide, 4:8. and lastly ZNS 4:4. This has become WURTZIT. Urzite. So if crystal system are known and coordination number also become known, then we can predict the geometry of following pattern of crystalline substance. Next, the density of crystal system. Density of crystal system. This formula is applicable. D is equal to Z into M and A into AQ, where D is equal to density in gram per centimeter cube. Z is equal to number of atoms present per unit cell. M is equal to molar mass. Na is equal to Avogadro number. A is equal to age length in centimeter. So if such terms are given, then we can determine density of crystal system. Our next study is radius ratio. What is radius ratio? Radius of cation by radius of anion. This is known as limiting radius ratio. Consider following table. Limiting radius ratio. Here coordination number 0 to 0.155. Second one 0.155 to 0.225, and third 0.225 to 0.414, and fourth one 0.414 to 0.732, and last 0.732 to 1. Here we write coordination number equal to 2, the second one the coordination number 3, third one coordination number 4, then coordination number 6, and last the coordination number equal to what? 8. So with the help of limiting radius ratio, coordination number can also be predicted. Our next topic is multi-layer close packing. We know very well there are so many types of packings are present in a crystalline substance. First one simple cubic, second one body center cubic, third one closed cubic pack, or you can say face center cubic, and last one hexagonal close packing. So first type of packing, the arrangement AAAA, ABAB, ABC, ABC, ABAB. Such are close packing, other two are not said to be close packing. Number of atoms 1, 2, 4, 6, and their coordination number 6, 8, 12 and 12. Packing efficiency in SC 52.4%, BCC 68%, CCP or you can say FCC 74%, SCP contain again 74%. We can determine packing efficiency with the help of formula. Examples are also given below. One important thing always remember for predicting the formula of compound: in close packing, if number of particles is equal to capital N, then number of octahedral void is equal to capital N, and number of tetrahedral void is just double of the octahedral void. Therefore, the number of tetrahedral void is equal to what? 2n. Our next topic is crystal defect. There are three types of defects may be present in a crystal system. The first one, stoichiometric defect. Second one, impurities defect. Third one, non-stoichiometric defect. Stoichiometric defect further classified two types: Scotty defect and second one, Frankel defect. Non-stoichiometric defect again further classified two types: metal excess defect and metal deficient defect. First, we have to understand stoichiometric defect, that is Scotty and Frankel defect. In Scotty defect, equal number of cation and anion are removed from crystalline substance. That's why the density of crystal system what? Decreases. This defect is also known as vacancy defect. Again we can write density of crystal decreases because mass of the crystal system become what? Decreases. Examples, you can write NaCl, AgBr, cesium chloride, etc. So this type of defect is known as what? Scotty defect. The second one is Frankel defect. In this defect, either cation or anion remove and goes from its interstitial site. Suppose consider A plus. Here the density of the crystal system remains same because there is no changes in the molecular masses, or you can say masses. So this effect is also known as dislocation effect. Dislocation effect. Density of crystal system remains same. Example, you can write ZnS AgBi, or you can write AgI, etc. The next defect is said to be what? Impurity defect. In this defect, in molten NaCl containing some strontium chloride present, some of the sites of Na plus ions occupied by strontium ion. Consider this figure. Here Na plus removed and Sr2 plus is present. Again this site is said to be what? Vacant. Na plus removed. Then defect create, known as what? Impurity defect. The second one, we can say one strontium, two positive charge, counterbalance two negative anion, that is said to be Cl minus ion. The last defect is said to be non-stoichiometric defect. Such defect are two types: metal excess defect and metal deficient defect. In metal excess defect, the number of cations always greater than number of anions. Here we can say the number of cations become smaller compared to number of anions. One thing always remember, in AGBI, if we consider a stoichiometric defect, then both defects are present. Both Schottky and Frankel defect present in the crystal system. At last, we will revise properties of solid. Three types of properties are available. The first one is electrical properties, second one magnetic properties, and last one dielectrical properties. In electric properties, three types of properties are well known as conductor, insulator, semiconductor. Semiconductors are two types, N and P types. Such concept you have already learned in physics. Our next property, magnetic properties. First one, paramagnetic. Paramagnetic means what? In magnetic field attracted by substance, if magnetic field become applied. Diamagnetic, there is no attraction in magnetic field. Ferromagnetic is what? Strongly attracted by magnet in magnetic field. Suppose alignment of electron in such a way that is large number of unpaired electrons are available, then crystal system is said to be what? Ferromagnetic in nature. But if the alignment of electrons are possible in such a manner and net dipole moment is equal to 0, then such substance are known as what? Antiferromagnetic substance. But if the alignment of electrons are possible in such a manner mu not equal to 0, then such substance are said to be what? Ferrimagnetic substance. Such electrons are called what? Alignment of electrons. We can say paramagnetic is a part of what? Ferromagnetic. At last, our property is dielectric properties. A dielectric is a substance in which an electric field gives rise to no net flow of electric charge. Piezoelectricity, pyroelectricity, ferroelectricity, and antiferroelectricity. So dielectric properties are four types. Piezoelectricity means a dielectric crystal which has a dipole moment can produce electricity. Pyroelectricity means some polar crystal upon heating produce a small current. Ferroelectricity means what? Dipole moment permanently polarized even in the absence of electric field. Potassium hydrogen phosphate is an example. And last, antiferroelectricity means dipole moment is alternate lattice point and moves ups and down. Example is PbZrO3 means lead zirconate. So such are the important properties for what? Solid. In next lecture, we will discuss our new lesson, that is solution. Thank you.